This week is about atmospheric optics, all the different stuff that the atmosphere and the sun can create. There's actually quite a bit. And there's several pictures here that are really pretty. You've got a little bit of a halo, you got a little bit of a sun pillar, you got some sun dogs, you got just the scattering of the blue sky, you got a rainbow, and then of course all the neat stuff you see at sunset that are especially caused by lots of haze, particles, pollution, that kind of stuff. When sunlight comes in, there's several different things that can happen to the sunlight as it actually comes into the atmosphere. It can either be absorbed, you can have it reflected, you can have it scattered, the sunlight can be refracted, or it can be transmitted. If you're absorbing it, then obviously and this could be clouds as well as just the atmosphere itself, but the gases and all the water droplets and all the stuff that's in the atmosphere can reduce the intensity of the actual rays that are coming in, which may affect your daytime highs. If you think about the deserts, there's a huge difference between, of course you can even do that on a real nice sunny day anywhere, on a hot day, but there's a huge difference between the shade and versus the light, and a lot of that's from the absorption of the gases, depending on how much is in the atmosphere. In the desert you can have a lot less water vapor, because water vapor absorbs quite a bit, as being somewhere else where there's lots of water vapor. So it's not having very much, and around here having potentially quite a bit. It can be reflected, it could be scattered, reflected where the radiation is redirected away. Think like a mirror kind of effect. It's not absorbed, just kind of bounces off of there. Another term for that is what they call albedo, which is just a percent of the visible light that's actually reflected. So it's just another term you might read in the book or online or something like that. Now, if anything's scattered, several different types of scattering that there's Rayleigh, there's me, and there's non-selective. The Rayleigh types of scattering is using the gas molecules that are in the atmosphere, and it typically affects shorter wavelengths. So you're going to see more of the blues and the violets, although our eyes are more sensitive to the blue wavelength than it is the violet. It tells us where the sky is blue on Earth and from looking at it from space, looking down. Me scattering, stuff that causes that would be fires, all the stuff that's put into the atmosphere from them, pollution, volcanic ash, that kind of stuff. And they don't necessarily favor a long or a short wavelength. Typically it'll appear a lot more in the gray. And there's what they call non-selective, and usually what causes those are things like the water droplets. When we're looking at some of the Rayleigh scattering, you're probably wondering, why does the sky actually look blue? And the sky looks blue because of scattering. So the light comes in from the sunshine into the atmosphere, and it strikes all those air molecules, everything that makes up the air, the oxygen, the nitrogen, carbon dioxide, water vapor, all that kind of stuff. And so the light hits it, it scatters, meaning it goes in different directions, kind of separates the beam. And whenever it does that with the gas molecules, it tends to favor the more blue and the violet. And really it favors the violet the most, but our eyes are only sensitive to the blue more than it is the violet, so the sky looks blue to us. And I might also explain why some people see the sky being bluer than others, depending on how sensitive their eyes are for the violet versus the blue. But that's why we have the nice blue sky, is because of the scattering, and that your eyes are more sensitive to the blue as opposed to the violet. Clouds, the same idea, except for in those clouds there's water droplets, so there's a lot different types of scattering going on, and so you end up seeing it more as a white color. Or of course you can get some of those darker shades in there, and a lot of that has to do with as much water that's in there, and the more water, the more it's going to scatter differently and look like it's a different color, and so you can get some of those really dark looking clouds as well. You can have refraction, you can also have transmission. So that light comes in, if it's refraction, it means that the light's being bent, and it's bent as it passes from one medium to another medium, and both of those have to be transparent, meaning you can see through them, like meaning passing through air, then passing through water, or something like that. And it bends because the speed of light is different when it travels through air versus when it travels through water. So you're changing the speed of it as it's entering through there, so affects your eyes. It will distort the image to you. There's transmission. Transmission, when that sunlight comes in, just means that nothing happens to it. It doesn't scatter, doesn't reflect, nothing. It just goes straight from coming in down to the ground. And if the atmosphere is really clear and dry, and there's nothing in the way for it to really transmit or to scatter or anything, then you can get about 80% of that sunlight that's coming in to actually reach the ground. And the drier the air, the faster the air is going to be able to heat up. And so you could have, think about like the desert where the sun's down, it gets so really, really cool, and then when the sun comes up, it heats up so much quicker. Because again, it's a dry atmosphere, and most of that light makes it all the way down to the ground and is absorbed into the ground. Now when you're looking at atmospheric optics, it has a lot to do with your perspective and where you're at. The ice crystals and clouds, and that's found in the atmosphere, can have different shapes, and depending on the shape that you get, depends on what kind of phenomena you end up with. So you've got one that's can be multi-sides, or you can have something that is more of where you're going to look through it at a point. So you're going to pass through, and then you're going to go through an edge or an end point. So you're going to go through a side, then an end point. And those types of ice crystal setups will give you different halo effects. When you're talking about your rainbows, you have to, all the other stuff, you're talking about like the sun dogs and all that kind of scattering, you get those nice little sun pillars where the light's just shining straight up. All that stuff, you'd be looking towards the sun. I mean, obviously don't look at the sun, it's not good for your eyes. But when you're talking about rainbows, the sun has to be at your back. So the sun's at your back and you're looking through raindrops, and that's how you see the rainbow. You can actually do it just for fun. Take a garden hose, stand with the sun to your back, and spray up into the air, and you can see a nice little rainbow that way. It's always fun to do if you have little kids around and show them a rainbow really quickly using the garden hose and all the sunlight. So you have to have the sun at your back, and you're looking through some raindrops, and then you're getting that refraction going on, so the bending of the light looking through the raindrops. And you can get a secondary rainbow because of the light passing through a secondary point, and they're always dimmer. You're not going to get a brighter one. I mean, sometimes it can look pretty bright, but it's not going to be bright as that first primary rainbow. But it's really neat when you can get two of them. You don't always do that, but you can. Let's see, some other things you can get from scattering of light in general. You've got crepuscular rays. Those are really neat. Typically you see those when the sun's low on the horizon, although you can get it whenever the sun's well above the horizon. If you have a large patch of clouds passing over the sun, then you can get some crepuscular, and that's where you can get what they call anti-crepuscular rays, the ones that shine down, because typically you see the ones that are shining up into the sky. And you get a nice little shadow, and then you get the bright light, and it looks like these rays that are emanating from the sun. They're really, really pretty. You can also get the little green flash. It doesn't happen all that often. It's a pretty rare event, and that's because technically you're not supposed to see the green flash, because all that scattering that's going on in the atmosphere, you really see more of the blue and the violet, and the portion that's green is really, really tiny, like real tiny that you can't see. However, if you have the right kind of atmospheric conditions when that's happening, you can actually have that act as like a magnifying glass, and you can see, kind of magnifies where that little green section is, and you can see what they call the green flash. Now the atmosphere you have to have that in is what they call a super adiabatic atmosphere, which means as you go up, the air gets colder as you go up. There's just what they call a standard lapse rate, a standard drop in temperature as you go up. Well, if it drops much faster than that, then it should, quote, should, then you end up with that super adiabatic air, and it will help magnify that green flash, and you can actually end up seeing it. So, which is why it's kind of a rare event, because you got to get that specific Gotta get the sun low on the horizon. You've got to have all the stuff to make, just to have the scattering in general for that, and then you have to have the atmosphere be at a perfect condition in order to magnify that little green section. So it doesn't happen all that often. And just a quick recap of some of the pictures that I showed earlier, where you can see the different atmospheric optics that take place. You've got the halo, and you have an inner halo, and you could have an outer halo. The outer halo is much more rare, but really neat if you get both of those. And then little sundogs don't necessarily have to have the full halo all the way around, but they could just have like a little, looks like a little mini rainbow on one side and a little mini rainbow on the other. And this one also has a sun pillar where you see the light shining straight up. Blue sky caused by scattering to the air molecules, and you see the bluer portion. And then of course a rainbow, where you get some refraction of the light. And there's also mirages, which I didn't really go over, but you can also get those where it's a distortion of stuff that's there, or it displaces it, but it's stuff you see off in the distance and it looks different, or it's changed in some format. So there's also mirages as well.